Welcome back to my talk. In the second part of my talk, we will address mathematical model when we apply currents to the object, and with the help of generative AI, we will create codes based on the given mathematical model. The model, when a direct current or low frequency current injected into the object between a pair of surface electrodes, then the current density, volt J here, inside the object due to externally injected current satisfies this equation, where sigma is denote conductivity of the object and E is electrical field or gradient U, or where U is electrical potential. And the equation that should be satisfied is the following equation, where G here is denoting current injected to the object. Now, to model the conductivity of the pendulum used in the experiment, which is a lamp deck, the conductivity consists of 3 layers: bone, this inside, and muscle in the region that surrounding the bone, and then we wrap a thin fat at the outer layer. Now, the injected current to the object is written in the following form, which is what is called as point electrode model, which is pointed by Hanke et al. In 2011. Here, P plus P minus here is denoting position of the electrode attached to the boundary, and I is current of the injected to the object. Now, in this work, we are using a large language model QN for generative AI, and directly we enter the equation here in what we call it latex-like. So basically, this is the equation stated in the previous slide. Just type it in to QN and then ask for the solution, and then QN give a response pages, I think around 20 pages. You can see the prompting and the response of QN in the accompanied paper, where in the paper provides MATLAB codes generated by QN. So after obtaining code which is generated by QN, we enter the third part of the simulation of the talk, which is a numerical simulation, or the code is executed for generating data. Well, or we might say the in silico experiment. In this experiment, we are using data from Geddes and Baker, where the skeletal muscle, which is the ring outside here, assign the value at 250 ohm centimeters, while the black dot here, black circle here inside, is a bone with value 16,000 ohm centimeters, and we inject current through the boundaries at the value 1 amperes. So, and we have the following results. We might see that you can see that the dot here is a potential, electrical potential, which is extended through the rectangle. The object itself is here, the circles here. The white here is the white circle here is actually the bone, and then the ring here is actually the muscle, right? And this circle there, red circle, is where the electrode position. Also the blue circle, so the red one is where the current entering the object, and the blue one is where the electrode exiting the object. We can visualize the potential here, and we can see here at the right hand side is the current density through the object, the analytical pattern. And we see here line here with arrows is a current density flowing from the top to the bottom electrodes, and we see that here in the middle there is almost no current at all able through the bone, which have high resistivity. Since we need the intensity of the current density, right? So the current density is stated as a intensity value. So we have the following image. Note that this is not image per se, but actually here the circle here is actually the current density value, real number, right? So this is even though in the form of image, actually this is the data generated by or from analytical phantom. In this case, a simple case, which is a 2-layer. Right? If we compare here between the experiment and the artificial data, you might ask, how come different? It should be stressed that image intensity in the MRI image has some sort of related to the proton or photon or it should be underlined that the image intensity of MRI images is not directly reflect the intensity of the current density inside. There is some physical principles which is related to the type of the tissues, which is unfortunately is outside of this talk. Next slide. So the current density, the artificial data generated from the analytical phantom can be used or will be used by reconstruction software. Here in the reported preprints, and also you might check at the YouTube video here about the software and the mathematical principle and the algorithm, also the method used. And that's will be the end of my talk. So here is the bibliography, and then what is the future direction? So basically the future direction is that we have chemical free contrast agent for MRI through non-invasive electrical impedance tissue properties. And also we can see that in previous video that some region will be unable to extract the data since have value 0, but that can be removed or painted using absolute electrical impedance tomography, using boundary measurement, which is maybe we will talk to, and I have to close my talk here, and I would